KCSE 2017 Paper 2 Mathematics Question 20 3 Dimensions Geometry Form 4.
First question, you're told to name the projection. Projection means that if you cast the line at point BE through the line at the bottom, so the projection of line BE, if I put my line casting a shadow here, automatically it will go through D. Therefore, the projection of line BE, it is BD. So that's what you're supposed to write there, BD. Next, you're told to 1 decimal place the size of angle AD. We have AD here, the size of angle AD, and BF. So I'm just going to take the projection again, BF. The projection of BF becomes BE. Therefore, you see, if I just try to extract this out in this form, so that I have D at the bottom, E on top, and A there, this on being 6 and the bottom being 12. This is the angle that they are talking about. So the size of this angle, I'm going to say, because this is opposite, and there we have adjacent under trigonometry. So opposite and adjacent goes with tan. Therefore, tan theta is equals to opposite over adjacent. Therefore, the angle theta will be the tan inverse of 6 over 12, which is a half. Therefore, tan inverse of that, we have 26.6 degrees. Then the next one, the angle between BE, the angle between BE, we have BE here, BE on the plane ABCD. So if I also try to remove that one out, we know that the projection of BE, it is BD. So we can extract the line D, E, B. So the one that I have here, it is 6 centimeters. So the line BD, to get the line BD, it is the hypotenuse of the base plane ABCD. So I'm going to use Pythagoras theorem to get BD. So BD will be the square root of 16 squared plus 12 squared. Then we find the square root. There I'll have 16 squared plus 12 squared. That is 400 square root. It is 20. Therefore, this line here, it is 20. And the angle that we are asked to find, it is the angle there. Therefore, we'll say again opposite and adjacent. Therefore, the theta will be tan inverse of opposite, which is 6, and adjacent, it is 20. If I press that on the calculator, we have 16.7 degrees. The next part, you are told to find the angle between the plane HB, CE, under BC, FG. So the plane that cuts at around this point here, that's the plane that they want. That's the plane that they want. Therefore, if I just try to extract it out, we are going to look for this angle that they are talking about there. Therefore, I'll just remove that out, because we know the upper one, this distance here is 16, and the one that is taller, the longer part here, it is 6, and they want us to find the angle here as the angle they want us to find. So also, because this one is 90 degrees, we have opposite and adjacent. So we are going to say tan inverse, because it's the theta we are looking for. Tan inverse of opposite over adjacent, 6 over 16. That one, I'll have my answer as 20.6 degrees for the 2 marks. Then next, we are told to point N is the middle of EF. Point N is the middle point of EF. The middle point is there. We call this point N. Calculate the length of BN. So we have BN. see that point. So we can extract this figure in that form, that from N to G, then we have this part. So if I draw it down, we'll be having something resembling that from B, G, which we have it is 6, and this is the point N, and point N is the midpoint. Therefore, if here it is 16, the midpoint means that it is 8. Yeah, so that is 8. We are going to use Pythagoras theorem because they are cut at 90 degrees, so that we can get the length there. If I come back to the figure, we know that this here it is 12 and this part it is 8. Therefore, taking that as a 90 degrees, we can use Pythagoras theorem first to find point N, G. Therefore, we will say that is 12 squared plus 8 squared. Therefore, this point here, it is the square root of 208, and that is what we're going to transform here, the square root of 208. Just to avoid errors, we're going to put it in this form. There now we can find that. So the square root of 208 squared plus 6 squared, then we find the square root of the whole thing. So if I press on the calculator, that I'm going to have 15.6 centimeters, because they're asking about the length of BN. And that is how this question is supposed to be tackled under 3-dimension geometries in Form 4. If you have any question, write it down in the comment section. If you need tuitions also, I am available. Just DM or call me and we will be able to plan. Thank you very much.